recording. Okay. Okay, so let's discuss more about the configuration, right? So one is this BGP related configuration, right? One is underlay BGP neighborship, right? With spine, that is to exchange this loopback IP addresses and VTAP IP addresses, right? Loopback 0 and 1, 2, so that each VTAP has or spine has route for other loopback addresses, VTAP or loopback 0 interface, right? AMLAC peer is basically underlay neighborship with peer, AMLAC peer, that is for backup, as a backup, right? So if your uplink goes down, you have backup from where you can read to spine loopbacks or other VTAPs, right? So that is for one. That, and EVPN neighborship is to exchange EVPN routes, right? And this EVPN neighborship will be with spine devices, right? Spine will act as a route server or route advertiser. Basically, they will forward the routes, right? Whatever they receive from other VTAP pairs. And as we discussed, we have redistributed connected so that we can, along with route map, so that we can advertise this loopback IP addresses, right, into the network, into the routing, BGP routing, right? And we just want to advertise only loopback IP addresses, only this two subnets, and that's why we have route map configured. Okay. And as we discuss, we have address family EVPN, where we need to activate only EVPN neighborship, and under address family IPv4, we have to only activate this two, not EVPN, right? So basically this is what the configuration is, right? Now let's check few other config, which is show run interface VXLAN 1, right? So this is VXLAN configuration. It's almost a same VXLAN source interface loopback 1, and loopback 1 is nothing but our VTAP IP address, right? So if you notice here, we don't have to configure secondary loopback IP address, virtual VTAP IP, right? In asymmetric in this one, right? So we don't need to configure secondary VTAP IP, correct? Because EVPN will take care of ARP and MAC and all that stuff, right? So we don't need secondary VTAP IP here. This command we don't need for asymmetric, but symmetric, this might be useful. So right now we'll skip this, but we'll discuss during symmetric IRB. Okay, the next section. What is the significance of this command? Just to give you, basically we are saying that between both AMLAC peer, we are going to use same AMLAC system ID. Okay, that is for east to west traffic. Otherwise, so that's what is this command means, but we'll discuss more about this during symmetric. Other are same, right? VXLAN UDP port number and VLAN to VNI mapping, right? So this is, so basically configuration, VXLAN configuration is almost same, right? There is no change. You don't need to configure this, right, for asymmetric. So it's same. And if you check further configuration, right, this is the MAC WAF configuration, right? So we have two VLANs, one VLAN 110 and 111. So we have advertised, basically we have, it's a VLAN based, right, configuration. For each VLAN we have separate MAC WAF. So basically we have separate RD and RT value, right? So this is VLAN based configuration. And redistribute learn means, as soon as we learn MAC address or R for any of this VLAN, we'll convert it into EVPN route and advertise, right? So that is, it's same as redistributed connected in routing, and here it's redistribute learn, right? You will advertise the routes. So I think, yeah, this is what the main configuration, right? Otherwise it's all fine. Okay. Any question? as far as config is concerned?
Vishal, could you explain the redistribute learn part again in the macro?
Oh, okay. Yeah. So basically this is right. So show 1 minute, MAC address table, right? Show ARP. What we want is, okay, do you guys know redistribute connected, right? Or redistribute static, right?
Yes.
So basically you will redistribute connected routes or static routes if you have configured static, right? Redistribute learn means as soon as you learn the MAC address, locally MAC address, you will redistribute. Redistribute means redistribute into EVPN, right? So as soon as you learn this MAC address, you will create type 2 route, local type 2 route. We'll see that. And then you will advertise that into the EVPN domain, right? To spine towards the EVPN neighbor, to EVPN neighbor. Okay. And same for ARP. So as soon as you learn the ARP address, right? ARP, you will advertise it to the EVPN over the EVPN. So that's why redistribute learn. So as soon as you learn, you will advertise that. Is it clear?
That's clear. I assume that by default it would just work that way, like
No. We need to give this.
Okay.
Okay. Same as we do give redistribute connected, redistribute static, right? Same way here we have to give learn, then only it will advertise. Okay.
Yeah, understood. Thanks, Vishal.
Okay, so this is BGP config. Okay, let's check now. So almost the configuration on all the VTAP is same, almost, right? It should be same. So if this is the another VTAP, right? So config
Vishal,
is
can you
yeah.
show the topology once?
Oh yeah. So this is the topology. Okay. So we have leaf 1A, 1B, right? What we check the configuration is on leaf 1A right now. Okay. Its peer is leaf 1B. There are two spines, spine 1, 2, and then another VTA pair is leaf 2A and 2B. Okay.
Okay. I took a screenshot.
Yeah, and there are, yeah, I think it's better you guys take the screenshot so that it will be easy. Yeah, because now we are also going to ping from H1 to H4 and we'll check the path, right? So yeah, better you guys take the snapshot. Let me know once it's done for you guys. Okay, so hopefully all of you have taken this. So, oh, sorry, shit. Yeah. Okay, so now this is leaf 2A. Okay, leaf 2A. 2A means this guy, other VTAP pair, right? So if you see, it's all everything is same. Obviously, this IP address will change, right? Neighbor and all that, but otherwise it's all same. Okay, V2 VLAN WAF address family, it's all same. In fact, RD and RT also should match, right? RT at least should match, right? Then only you will import the routes, correct? For both VLANs. Now let's check the configuration on spine, right? Okay, so on spine we have EVPN overlay peers, right? Correct. So it's a EVPN configuration. Obviously here EVPN overlay, it will have basically it will have neighborship with all your 4 pair VTAP pairs, right? 4 VTAPs. So basically this spine will have EVPN neighborship with 1A, 1B, 2A, 2B, 4 EVPN peers, right? So that's what here it is, right? 4. So it has 4 EVPN neighborship, And also this is underlay, EVPN underlay peers, right? That is again with all the 4 spine devices, right? To exchange the loopback IP address. So with this physical IP address of ET1, right? It will create EVPN, normal BGP neighborship, right? To exchange this loopback IP addresses, right? So that is underlay, and another is overlay. In this, you don't need to configure peer neighborship, right? MLAC peer neighborship BGP, which we used to have between VTAPs, because spine 1 and 2 are independent. They are not MLAC, right? So you don't have to configure peer, because all are connected, right? If this neighborship all 4 goes down, that's fine. That spine will be out of picture, right? So that's why you don't need to configure this neighborship between 2 spines. So there are only 2 BGP, right? One is underlay with VTAPs and another is EVPN neighborship. Okay. Here also you will configure redistribute connected, right? And with route map, so that you advertise only loopbacks, right? And then address family EVPN activate, and IPv4 you just activate underlay peers. Okay. So can you tell me why, what is the difference, right? There are no WRF configuration here, right? If you compare this with, if you compare this configuration with this, we don't have this, right? Can anyone tell why?
The VRF is only locally significant. Right? This is spine is just my transit.
Yes, it is transit. Okay, tell me whether on spine VXLAN configuration will be there.
VXLAN configuration
On spine, like this one, on leaf V,
no.
this config.
That should be actually no.
Sorry?
Because,
Not be.
no.
No, right? Because spine don't have,
Yeah.
it's not, it don't have to extend the VLAN. No host connected behind spine, right? It just, so basically you don't have any VXLAN also configuration under spine, and that's why you don't need MACWOF configuration as well, right? So just spine will just receive the EVPN and BGP routes, and it will just advertise that. So you will not have any VXLAN config in this means in spine. Is it? So config of spine is pretty, small. It's just have BGP config, that is also overlay and underlay, right? No peer. And then interface IP address, and that's it, right? No VXLAN config, because you don't have any host connected down here, right? Spine is not acting as a gateway. Even there is no SVIs, okay, on spines. It just will receive the route and forwarding, and that's why it should have BGP and EVPN configuration. Okay. Any question?
Vishal. So, so talking about leaf, right? If we have multiple VRS, so right now we know that the ARP and MAC is populated from, sorry, type 2 route BGP VPN table is populated from MAC table and the ARP table, right? But how will it work if there are different VRS? Like, will it be single BGP VPN table or will it be different?
Yes. So even though on your switch, we will discuss this when we talk about symmetric IRB or L3 VPN, but just to answer, right? For all the WRF, so if you remember, right, we have discussed one point. Let me, okay, 1 minute, we'll slideshow first, right? Okay, so let's take this as a one VTAP switch, right? and we have different WAF, right? Customer A WAF, customer B WAF, right?
Okay.
Now there are, and this is in between device like spine one. Now one way is, you know, you have BGP neighborship to exchange route between all the WAF, right? WAF to WAF, right? So what will happen, whatever routes are here, you advertise it to this guy. And then again from here to the other VTAP, right? To that WAF, right? Now, if you have 10 WAF, you need 10 different
10.
neighborship, right?
Yes.
For each WAF, separate neighborship and separate routing table, right? Which is not obviously scalable, correct?
Yes.
So that's why what we use is RD and RT, right? To distinguish or unique, make this routes unique, right? So that we don't have to configure different EVPN neighborship, right? So now we have two WAF, but we have only one neighborship, it is EVPN. There is no WAF on spine, right? Spine, there will be no WAF. So what you are doing is whatever routes from here and here, right? You convert it into VPN v4 route, add RD, right? And also RT, route target. And route target and RD and RT is what will specify, or it will help you to identify that WAF, especially RT, right? Route target. So basically now you have only single EVPN table, okay? Where all the routes, whatever routes from all the WAF will be stored in only single VPN tables, right? And that will be advertised to spine. Spine has also single EVPN table. Obviously one default route table is there, default routing table, right? That is there. But otherwise EVPN table is single. And here also that there is only one EVPN table, right? Where all the routes of different WAFs will be here.
Okay.
Now what you do, now this is WAF A and B, right? Now you have all these routes you received. One route is for WAF A, other is B, right? B. Now how you will, import this route into which route to which WAF, right? So that is based on your RT configuration, right? Route target. So you will check route A. What is the route target? If route target is matching import of route of this config, you will import A into this routing buff, right? B route target matching to this B route target, you will import it to B routing table, right? So that's why we have RD and RT, right? So that we can have only one table for all the EVPN routes, and based on RD and RT, right, we will distinguish which route is for which WAF and we will import into that routing WAF.
Got it. Same like this type V4, it converts to VPN V4.
Yes. Okay. Is it clear? Any question?
No.
Okay. Okay. So basically we have only one EVPN table, right? So if we check show BGP EVPN summary here. So this has EVPN neighborship with both the spine 1 and 2, and it will advertise the route and receive the route. Okay. One more thing which I forgot and which is very important. Without that, this will not work, right? EVPN, that is configuration of multi-agent. So you have to make sure that you have enabled this service routing protocol multi-agent, right? If you have not done this, EVPN will not work, right? So there are possibility that customer might have forgot in new implementation configuring this. So just check this, that this is configured. On many devices, you need to reboot after configuring this, but later it might have changed that you don't have to. So just check that as well, that whether reboot is required or not for that specific platform, and if customer has done or not. Okay. So this is the one which you have to make sure that this is enabled on the device. Okay. Okay. Any question? Okay. So let's go through some of the most common commands, right? Which is for VXLAN also we used to run, and for EVPN also that is useful, because under again it's top of VXLAN, right? So yeah, one command is this. It is same as what we run even in hidden replication, right? The difference is now you will see that replication flood mode is hidden with floodless source EVPN. So if you might have seen here hidden replication or CVX something, right? SCSV something. If you are using EVPN, here it will show as EVPN, right? Floodless source as EVPN. Okay. Remote MAC learning is also via EVPN. So basically it will also reflect that, hey, MAC learning is now through EVPN, not data plane learning. Okay. And VNI mapping, VLAN to VNI mapping, this is what you have already configured, right? So this is all, flood list, right? This flood list populated. So this is all, and MAC router MAC, shared router MAC. So see, because of that command, it reflects that MLEC shared router MAC is this, right? Same MAC address on both the VTAP pair. Okay. So yeah, so you will basically see this EVPN difference. Okay.
This is the MLAG system ID.
Show AMLAG detail, right?
Mhm.
So AMLAG
Yeah, system ID.
01734B, yeah, it's same. So but the you can also configure any unique if you want to by using this command, right? If you don't configure, it will take this.
Okay.
Okay. So any question on this command? It's pretty straight. Basically, it's same. Just it will reflect that you are flood list and that is populated MAC is learned through EVPN, right? There is one more command, show BGP EVPN instance. Basically, that this will tell you that you are, you have used VLAN base or VLAN aware bundle, right? And also RDRT value, basically MAC WAF related information. So basically, if one EVPN instance is VLAN 110 or MAC WAF is 110, right? RD value, what you are using, route target you are using, import and export for that, which type of service you are using. So VLAN based, right? Local IP address and encapsulation is for VXLAN, right? So basically this will give you detail about which EVPN instance you are running, right? VLAN based or VLAN aware. Obviously you can get this from configuration also, right? But yeah, you can use this command as well to know the what type of instance you are running, service model you are running. Okay. Next is again show BGP EVPN summary, right? So EVPN neighborship, how many routes are received, advertised, right? So that is one. And one more is so VXLAN flood VTAP, right? So flood list, VXLAN flood list, other VTAP. So for both VLAN 110 and 111, this is the another VTAP IP address, right? So we are here, right? So our VTAP IP address is this orange 254.3 for both of this common. And another VTAP IP address is 254.5, right? So that is what we have learned here, populated here, another flood list, basically, right? Can you tell me how we have populated this based on which information? This is automatic, right? Not manual.
Type 3 route.
Type 3 route, right? So let's check type 3 route, right? So run, okay, show BGP EVPN, right? Route type. So if we want to check specific route type, right, then this is the command. routes, EVPN routes for specific route type. So which one we will use? Type 3, right? Type 3 is IMET. So IMET, right? And if you want to check it on for specific IP address like this, right? We can give this. So it will show us all that. But if we want to check all, right, IMET detail, right? It will give us detail output of all the type 3 EVPN route. Okay. So let's check the first, so see basically what will happen as soon as you configure VXLAN 1, right? As soon as we configure this, right? VXLAN related configuration and VLAN to VNI mapping here, and also show run sec BGP, right? MacWorf. As soon as we configure this MacWorf, and also provided this also configuration is there, it will automatically generate type 3 route, right? Type 3 route. Okay. So as soon as you configure this and this, and same for also VXLAN, it will generate type 3 route, right? And this is how it looks like. Okay. So this one. So what is the VTAP IP, local VTAP IP? 192.168.254.3, right? This VTAP is this, right? Show IP interface brief, loopback 1. So this is the one VTAP IP address, right? So what it will do is, and that is also configured here, right? Loopback 1, source interface. So what it will do is, for that VTAP IMET route is generated, right? So this is the 255.3, right? Route, RD value, route distinguisher. This is for VLAN 110, right? So this route VTAP time IMET 3 route is for which VLAN 110, right? This RD value is for this guy 110. So it generates type 3 route for VLAN 110, right? Local. So basically this route is generated based on this configuration locally, right? From 0000 origin IGP matrix. This is all, BGP related. Extended community route target is 10110. So you are using this route target, right? For VLAN 110. Tunnel encapsulation is VXLAN. VNI is 10110. So again for VLAN 110, VNI is 10110, right? So basically you have created type 3 route, right? PMSI tunnel ingress replication, MPLS label, that is same as VNI, and tunnel ID is again 254.3. Okay. So with this information, you have generated type 3 route. Okay. And similarly, you have generated type 3 route for another VLAN 111, right? So this is the RD value for 111, and route target is also for 111. VNI is 111. So basically you have generated two type 3 routes, right? Two type 3 routes for both the VLANs for your VTAP IP. Basically you want to tell the other VTAP that, hey, I am the VTAP this 254.3, and I am part of VLAN 110 and 111. Okay. So for any traffic, bump traffic for VLAN 110 and 111, you can reach out to me, or basically you can send me traffic, bump traffic, right? Because I might have host for that particular MAC. Okay. Is it clear? Any question on type 3? Okay. So this type 3 is generated. Now let's check that we will now advertise this to our neighbors, right? So show BGP neighbor, right? So this is one spine 1 neighbor. So spine 1 neighbor, right? EVPN. We want to check EVPN route, advertise routes, right? And detail, correct? So basically now we'll check that what are the routes which we have advertised here, right? Advertise. So we can say to spine one, right? So right now we want to check the IMET route, right? So this is the IMET route, right? For 254.3 is this VTAP IP address. 10110 means for VLAN 110, right? RD of 110. We have added AS number of our own. So this is our AS number, right? 65101. So this is the route we generated locally. Now we are this previous one, and now we are advertising it. So we have added our AS number, right? This is all, it is generated from this guy, our VTAP IP. This is the loopback. Extended community route target A. This is 10110. So this is same, right? What we generated locally, correct? This all are same. We have just added this AS number when we advertise that to the spine one, right? And similarly, this another route for 10111, okay, which we advertise to the spine one. So both the locally generated route, we have advertised it to the spine one, okay? Any question? Are you following me? Or if you want, I can repeat if anything is not clear. Okay. Do you guys want me to repeat?
Just one thing. Why does it mention MPLS label?
Sorry.
So in this, why does it mention the VNI ID as MPLS label?
Oh, okay. So see, basically in field, if you check, it's only one, right? VNI or MPLS label. Okay.
Yeah.
But basically it's because it shows different, that is, we reflect it as a different way, but it will be either VNI or MPLS. So if you are using basically VXLAN, then it will be 10110. If you are using MPLS as data plane, then it will be MPLS label. But that will be only one field for both.
Okay.
Yeah. Okay. So yeah, so we have advertised this route. Now let's check on spine, right? So show BGP EVPN summary, right? So we have advertised from DC1 leaf 1A, right? From this guy, leaf 1A. So let's check on spine one. Show BGP neighbor, right? From leaf 1A, EVPN routes received, right? And if we want, we can, yeah, detail. So as you can see here, that routes, right? What advertised by leaf 1A, this guy has advertised. You are able to see that routes here, right? So that is 254.3.10110, and you have received it through this guy, right? Both the routes. If you check same, so see, as leaf 1 has advertised, leaf 1B would also have advertised same routes, right? Because it would have also generated locally routes, right? So if you run this, right, for neighbor of leaf 1B, you will also see the same routes, right? This is 1B. So same routes are there because 1B also would have advertised the same route, right? So once this guy receives this route, it will again advertise this to another VTAP pairs, right? So if we check show BGP neighbor, right, 2A, right, leaf 2A. So this guy, leaf 2A. So it has received this type 3 route, it will advertise here, right? And here. So if we check type 2A, so neighbor this 2A, right, EVPN advertise routes detail. So basically it has advertised this routes, right? It has added its own AS number as well, right? 254.3.10110, and it is advertising it to the other VTAP leaf 2A, right? So this is one, okay? Same route, see, same RD value, if you see, right, and that also it is advertising here, right? So 254, 1 minute. Oh yeah, this is 111. So 110, 111, right? Two VLAN. So this is one route information which it has received from which pair? Can you tell me, is it from leaf 1A or leaf 1B? So see, this guy is advertising this route to both 2A and 2B, but it would have received from 1A also and 1B also. So which one is this? 1A or 1B? Highlighted one.
It will be 1A.
1A. Based
Yeah.
on what?
The router ID. Router RD.
Okay, yeah, RD is correct. And one other, oh man. Another thing is this one, if you have noticed, right? This C from 255.3, right? 255.3 is this guy, right? This loopback 0. For EVPN neighborship we have used, right? And if you have advertised through leaf 1B, it will show 255.4, right? So which is this? Other two routes, right? Okay. So basically, yeah, spine will advertise it again to the leaf. And now let's check leaf 2A, right? So leaf 2A, show BGP EVPN route type IMAT detail. So it will show, you can see here that you have received this route 254.3, this VTAP route, right? For VLAN 110. And you have two paths available, right? Two paths available. One is you received is from one VTAP, right? Or basically one spine 1, and another you have received from spine 2, right? So you have received from spine 1 and 2 because both spine would advertise same route to leaf 2A. So you have two paths, spine 1 and spine 2 for same VTAP address, right? And other information is same what we have seen. Okay, same for 111. And then again 254.3 you will receive from another leaf 2A, which has also again both paths, spine 1 and 2. Okay. So based on this type 3 information, right, EVPN route it receives, it updates its flood list table. So now it will update that for VLAN 110 and 111. This is the VTAP IP address. Just a minute. Okay, is it clear? Any question? Okay. Okay, so yeah, this is all about type 3 route, and similarly, let's go through type 2 routes, right? MAC and ARC. So let me start ping, right? Let's ping. So basically what I'm doing is I'm pinging from this host 4 to host 1. Okay, host 4 to 1, which are both in different subnets. So this is in VLAN 110 and this is in VLAN 111, right? So what will happen? This will send out our basically gateway, right? Packet to gateway. Maybe if ARP is not resolved, send out ARP request, resolve it, send packet to the gateway in VLAN 111, right? From here, it will check the destination IP, which is 10.1.10.101, which is directly connected into VLAN 110. So it will locally route the traffic in VLAN 110, and then VXLAN bridge the traffic, right? Bridge the traffic through VXLAN encapsulation and forward it here. Okay. So now, as soon as this guy sends the packet leaf 2B or 2A, right? Anywhere. It will learn the MAC and ARP, local MAC and ARP of H4, right? So first of all, it will learn the locally MAC and ARP. Based on that, it will generate type 2 route, right? And advertise it to all the peers, right? Through spines. So it will advertise to spine and spine will advertise to all the VTEPs, type 2 routes, right? So let's check that. So I am continuously pinging from host H4, which is connected to leaf 2A and 2B, 2A and 2B, right? So let's go on leaf 2A, right? Leaf 2A and check the MAC address table, right? Show MAC address table. So what was the MAC, right? So MAC is 5640, right? 5640. Let's keep ping running. So 5640 is your port channel 6, right? So it is connected to port channel 6. You are learning locally MAC local in VLAN 111, right? See, this host is connected in VLAN 111, right? It's so you are learning MAC locally in VLAN 111 from this port channel 6. Okay, so you have learned the MAC locally, right? Let's check the ARP. So you have also learned ARP, right? For this guy 10.1.11.104. So this is the IP address 10.1.11.104, right? So you have also learned the ARP locally, right? 5640 VLAN 111 port channel 6, right? So you, as soon as you learn MAC and ARP locally, because of that command, right? Redistribute learn under VRF, redistribute learn for this VLAN 111, it will generate type 2 route, right? So it will generate show BGP EVPN route type 2 route is what? MAC IP. And let's run detail. Okay. Okay. So local, we have to check the local routes, right? It has generated, it should have generated local route, MAC IP route. So this is the local routes, right? This other are we have received from other peers, right? Through spine. So this is the local route. This is the 5640 MAC address, right? MAC. So type 2 route for MAC. Route distinguisher RD value, what we have configured here, 255.5.10111. So this is the one, right? 25. For VLAN 111, 255.5.10111, and this is the RT, right? So this is the MAC in our RD value locally generated, right? Route target is that VLAN 111 route target. Encapsulation is VXLAN. VNI is again 10111, VLAN to VNI mapping. ESI is 0 Ethernet segment, right? Because this is MLAC pair. It's not multi-homing, correct? So you have generated type 2 route for MAC. Similarly, you have generated type 2 route for ARP, right? IP plus MAC binding. And other information is same, RD, RT, and all that, VNI. Okay. So you have generated type 2 route for MAC and ARP as soon as you learn the MAC and ARP locally, right? And then you will advertise this route. So EVPN summary towards the spine. So BGP EVPN, show BGP neighbor, right? Spine 2, EVPN, advertise route, detail, right? So I met, where is our MAC IP, right? Yeah, D5. What was that? D540? 5640. 5640. Yes. So this is the one, right? 5640 is advertised, right? And MAC and ARP both, correct? So basically we have advertised this generated locally, advertised by adding our AS number, right? Other information is same. So we advertise that to the spine. Okay. Is it clear? Any question?
Yeah. Vishal, so now suppose we are running warp, right, between 2A and 2B.
Yes.
Okay. So will the R be synced between the M line if only one learns it? Like 2A learns the R, right?
Yeah,
Uh,
it will sync to 2B. Yes.
okay. And what if it is just a VRRP? Like one would be the master and one would be the backup, right? Is it still the
Okay.
same?
VRRP. I'm not. I have to check whether we support VRRP plus EVPN or how we
Okay.
are doing, because we have not seen any mostly any case with VRRP plus. We have to check
Okay.
whether VRRP and EVPN is supported or not,
Hmm. Okay.
and
So,
how basically we are behaving on that.
okay.
But
so,
VRRP also, you will have
uh-huh.
virtual IP which will be only on one
Yeah,
master, right? So
yeah,
basically master should advertise that route if we are supporting, and basically master only will take care of this, right?
yes. That's my
Route.
question. Like, will the backup also
Backup
be
will forward
advertised
the traffic to the gateway,
to
basically
the?
to master.
Uh, hmm.
Standby, basically. Yeah, standby will forward. So
Okay.
that's how it should work. But yeah, I have never tested, or first of all, I have to check whether VRRP plus EVPN is supported or
Okay.
yeah.
So, but in this scenario, once 2A learns the ARP, it will sync the ARP table as well
Yes,
to
yes,
2B. Okay.
yes,
And
yes,
then 2B should also advertise the type 2 route to the
yes. So
spines.
let me show that, right? 2B. So 6 and 7 is 2B. Okay. So show ARP, right? So see this ARP is learned here, right?
Okay.
So show BGP, EVPN, route type, MAC IP. So it has created this type 2 routes. You want to check detail 5640, right? See, so without detail, if you want to check, this is the route it has created. See, 5640 MAC and MAC plus IP, right?
Okay.
MAC IP detail.
There should be one from 5 as well because we have IBGP peering, right?
No, see, okay. So IBGP peering is not EVPN, right?
Okay.
It's
Yeah.
so
It's
you have to
underlying.
make sure, see, underlay IVPN. But see, this is one good point. Generally, we have seen customer does so basically by mistake or whatever, right? EVPN, IBGP peering also they activate, right? So basically, already you have underlay IBGP, which is necessary, right? But you don't need to have EVPN neighborship between this neighbors. Then what will happen? These routes, right? EVPN routes also will be exchanged here, and that might create loop or race condition. Sometimes what happened because of race, see, you should always install this EVPN route, right? Not this one you receive from here. But because of race and it might create routing loop or all that stuff. So we have seen one or two instances, means customer, where they have enabled EVPN basically between IBGP peer also they have enabled EVPN activated, right? So that might cause issues related to loops and all. So basically, even though they need this EVPN neighborship, they should have put route map so that same route is not advertised again and again, right? So that, yes.
Okay.
But yeah, good that you have asked that, right? Yeah. So just keep in mind it's underlay, okay? Not EVPN. EVPN is only with spine. Okay. Any question? Any other question? Okay. So basically, yes. So your leaf 2A will advertise that route. On spine, we will receive this route, right? EVPN route type, MAC IP detail. So 5640, right? So yeah, this is the route we have received, right? From that spine leaf 2A, right? So this is the what it has received, and then it will advertise to leaf 1A, right? And basically, let me log in again to leaf 1A.
This spine one you should see from 2B as well, right?
Yes, yes. So basically this spine one, you will receive route from 2A and 2B. Okay. So yeah, both. And that both routes will be advertised to leaf 1A. So if we check leaf 1A, you will see routes from same MAC and IP route, MAC and IP route from both the leaves, right? So one is 56. This is one set. Okay. 5640 MAC plus IP route, right? ARP route. From which leaf? 5.5, right? Dot 5 is leaf 2A, right? Leaf 2A generated route. But if you see here, the same route is there, right? ARP. From which leaf?
From 2B.
2B, right? 6
Yeah.
255.6. So basically you received here leaf 1A, received route MAC IP ARP from 2A and 2B, right? And similarly, you will see MAC route from 6, right, which is 2B, and MAC route from 5, which is 2A. Okay. And also each route you are receiving through two paths, right? Two spines, both the spines,
Yes.
spine 1 and 2. Okay. So you are receiving MAC IP route, ARP route, which is originated from leaf to A, right? Through two spines, both spines. Yeah. Similarly, route ARP initiated by 2B through both the spines, spine 1 and 2, right? Spine 1 and 2.
So there would be 4 basically parts.
Yes, yes. So for one ARP, you have 4, paths available.
This would all be ECMP, right?
Yes, ECMP. And once you receive this, right? Once you receive this, what you will do is MAC and so MAC address table, right? So on MAC address table 5640, you can see that it is pointing to VX1, right? So you have learned this through VX1 interface. So you can check VXLAN address table, right? So VXLAN address table 5640, and it shows that it is through VTAP 254.5, which is nothing but this VTAP, right? For both, it is same VTAP, right? So it is VTAP this, right? And how to send this VTAP? Show IP route. So you see there are two paths, right? Spine 1 and 2, correct? So basically you can send it to spine 1 and 2. This is physical IP addresses. Physical L3 IP address, this here, this. Okay. So on this, you check that how to read this VTAP. You can send packet to this guy or this guy. Okay. And same for ARP. So ARP also, if you check, right, 11.104, you have this. Let me see if ping is still running. Yeah, it's running. Okay. Right. So yeah, this is the MAC. is learned over this VXLAN1. Okay. So that's how using type 2 route, you will update your MAC and ARC table, right? Based on this routes, what we have received. Is it clear? Any question? Okay. So just guys, please try to run lab, spin up lab, right? If you are using Supremum or any other physical devices, that's fine. If you want to use this COS, we have document, otherwise reach out to me, I'll help you to spin up the lab. But now we have completed asymmetric, right? Almost, right? We might have one session where we can introduce some issues and troubleshoot, right? But otherwise this is over, right? So just try to spin up one lab and try to play with this and ping me if you stuck anywhere, okay? Or if you want to spin up the lab, okay? But just please try and run through the lab, okay? Any question?
Yeah,
Yeah,
Vishal, can you go back to the command?
yeah.
Like suppose this host 4 was not in MLAG and was an ESI.
Oh,
So
this two.
yeah, any of the hosts basically.
Correct.
H4. So then we would see on the leaf 2, if you take for example H1 as an ESI, then on the leaf 2A, 2B, will we see in the VXLAN address table that H1 is behind an ESI?
Okay. So no, so VXLAN address table will still show you both leaf 1 and 1B, okay? Basically this VTAP IP address, which is common. Okay, so now in that case, this VTAP will be different, okay? This VTAP IP will be different. So when you run show VXLAN address table, that MAC address, right? H1's MAC address will show you both the VTAPs, okay? Leaf 1A VTAP and 1B VTAP, okay? So it will show it as a both the VTAPs.
Okay.
But see how it came to know about this, that is because of type 1 update, ESI type 1 update, right? Type 1 auto discovery. And so because where you will send out Ethernet segment identifier and all that information, and even 1A where the locally MAC has learned, I have sent type 2 route. So combination of type 1 and type 2, you will create this one.
Okay.
Okay.
Right. In the MAC address table, it will still show it is not on VX1.
Yes, it will just reflect
VX1.
Yes.
Yeah.
So MAC table will just say VX1, right? But when you do show VXLAN address table, it will tell you that, hey, it's 1A and 1B, both VTAPs.
Okay.
Okay. So in fact, if you want to, run some, so once you are done with asymmetric, we also have in COS topology for this guy, right? Symmetric, multi-ohm. So in fact, you can run this, spin up this topology if you want to check something on multi-ohm.
Okay.
Okay. Let me here only because, yeah. So you can spin up this topology, AVD asymmetric multi-ohm. Right now I have spin up this AVD asymmetric IRB, right? You can spin up asymmetric multi-homing where you will not have a MLAG, and you can check that behavior. Okay. Okay. So any questions? Fine, then we'll stop here. Please try to do some lab, right? If you want access, ping me, okay? And yeah, we can spin up the lab, but yeah, try to do some lab. Okay.
Okay.
Okay, thank you guys.
Thank you, Vishal.